Any weapon is a tool. No matter how excellent, its effectiveness depends ultimately on the skill of the man using it. And skill comes only as the fruit of experience. Thus, the problem has always been the same: how to practice realistically for the battle environment. As man evolved newer weapons, he also created the need for a new kind of practice, a new target. Parity between training and the real world had to be maintained. Today, supersonic aircraft are key elements in the arsenal of every modern military power. So, to train effectively, the target must have the speed, maneuverability, and unpredictability of a good manned fighter, but without its associated risk or expense. The target must be a good, demanding teacher. Firebee 2 is such a target. Teledyne Ryan's Firebee 2 is the solution for today's supersonic combat simulation problems. The drone measures some 29 feet in length and about 9.6 feet across the main wingspan. Fully fueled and configured for a typical mission, it weighs 2,529 pounds, with more than 700 pounds of fuel for 65 minutes endurance. The speed-altitude envelope of Firebee 2 is large. Mach 1.1 on the deck, Mach 1.8 at 45,000 feet, and 1.5 at 60,000. These flight characteristics were carefully designed to cover the effective combat spheres of the world's best operational fighters. Firebee 2 is obviously not a docile or predictable target. At 15,000 feet, Firebee 2 can pull 5G turns, nearly 80-degree banks. It can make a 180 in 1.1 nautical miles while at Mach 0.95. Such high G turns can be combined with climbing or diving patterns for even greater maneuverability. And Firebee 2 can be directed to exploit this performance fully. 10 channels of downlink display telemetry and 38 remote command channels put the controller totally in command. The mission versatility is remarkable. One mission could begin with a climb to 50,000 feet, then cruise for 26 minutes at Mach 0.9. Dropping its external fuel tank, Firebee 2 accelerates through Mach 1.5 and climbs to 60,000 feet for an 18-minute supersonic dash. Another mission would begin at 500 feet with a 16-minute cruise at Mach 0.8. After tank jettison, the Firebee 2 drops to only 50 feet with an automatic low-altitude control system and levels off for a Mach 1.1 dash lasting over 4 minutes. An augmentation system can make the radar reflectivity of Firebee 2 match any of dozens of specific aircraft. By varying frequencies, polarizations, and power, signatures can be varied to represent either fighters or bombers. Infrared signature augmentation is also available and simulates a number of differing operational aircraft. Both IR and radar guide points can be located in the wingtips to minimize damage to the drone from a successful strike. But because effective training demands learning from misses too, Firebee has been designed to accommodate both radar and photographic scoring systems. Firebee 2 can be airdropped or rail-launched from land or sea. In addition to its aircraft roles, it is a good simulator of current naval cruise missiles. As such, it can provide fleet defense forces with actual firing runs or radar tracking exercises. Firebee 2 is highly cost-effective because it has been built to be recovered and reused. After the mission, the drone can be guided to a suitable recovery site where it can be picked up by a helicopter or ship's crane. Moreover, a mid-air retrieval system has been designed for helicopter recovery prior to touchdown. After water recovery, a good crew can ready Firebee 2 for reuse in only 24 hours. After mid-air or ground recovery, in only 10. Recoverability is further enhanced by a number of flight safety systems. Below 15,000 feet, for instance, an automatic climb sequence is activated by the loss of engine power or by generator failure. At a safe altitude, ordinary parachute deployment begins. A similar sequence starts when the command signal is interrupted for a predetermined period. Perhaps best of all, Firebee 2 is not just a drawing board concept, but a supersonic drone system currently in wide operational use by all three United States military services, and being adapted as a transonic research aircraft by NASA. And the Firebee 2 system is just beginning to grow. A new air-cooled turbine will extend performance to Mach 2 in excess of 60,000 feet. Design is complete on an increase for the internal fuel supply, which will cut the cost per supersonic target presentation by 1/2, while a consolidation of tracking beacons, command links, and data links will further minimize ground support and logistics. Training realism is still the essence of growth. It flies smart, like another pilot.